Okay, I think the clock is starting. Good morning, CERN. How are you? Cool. So, my name is Stephan Janssen. For the people who don't know me, I'm the founder of Devox, Devox for Kids, Devox Genie, also co-founder of Vox, the Vox Days. And I have my co-speaker here.
I'm Alfonso. I work at Oracle Labs, particularly on the GraalVM project. I work in a slightly different thing. So I work on Espresso. It's all about compilers and optimizing Java. So we are giving this slightly different talk this time.
Yeah, and you can follow us on the Blue Sky. It seems a trend to move away from Twitter, which we've both done. And so the talk about, or the title about the talk is AI-Augmented Programming. And if you take the first letters, that's AAP. And AAP in Dutch, because I'm from Belgium, is actually monkey. And the reason why I call it monkey is that what we are starting to see is all these AI code assistants, they're basically replacing Stack Overflow. Now, instead of copying and pasting code from Stack Overflow, we're now copying and pasting code like a monkey from what the large language models produce, right? And it's clearly a trend. The good news is that these large language models are becoming smarter and smarter with every new release. I mean, if you look at OpenAI 03, it is expected that it has an IQ of 157. Now, I know if you're at CERN, that's just an average IQ level, but it's higher than mine. So what we want to talk about is about how to use Java, full Java stack, to do inference within an IDE. That's what the talk is about. And so the first thing you would need to know is that you already have two options if you want to use a large language model. You can work with local LLM providers or with cloud LLM providers. If you work with local ones, then these are the four options that are regularly showing up. The bottom one is Llama CPP. As the name says, it's written in C++, so it's very performant. And that's like the Swiss Army knife for large language models, because LM Studio or Llama and Jan, they actually use Llama CPP underneath it. It's a bit like, it reminds me of FFmpeg. I don't know if you did any video analysis. FFmpeg was like the Swiss Army knife for video, right? Well, Llama CPP is the same thing. The one I use is Ollama, but because I build a plugin, I actually try to support all four of them. The good thing is that it runs on Windows, Mac, and Linux, so there's no excuse of not doing it. Now, the reason why you want to do local LLMs, I'll mention that later, but it's obvious, it's privacy. Now, once you have a LLM provider, you still need a model as well, right? So the provider is just to do inference. Inference is when you talk to an LLM and you get a response back. But you still need to download a model. And so the models for local ones there's like three main ones that people use. The first ones are the Llama ones, 3.1, 3.2, 3.3 from Meta. Meta, Facebook, they were a bit behind, so what they did is that, okay, if we can't beat them, we'll just beat them by just open sourcing the best models out there and basically try to, get the market share from OpenAI. The one I use locally is 3.1. That's a very nice one, very small, very fast. But there's other ones as well, like Qwen 2.5. But recently, the big excitement that I see in the AI space is the one from DeepSeek Coder. DeepSeek Coder is a Chinese company, so watch out, right? But it's version free, and it's really, really not expensive. They basically, if you look at Anthropic, the cloud ones, they're a fraction of the cost. And that's version free, and it's very good. So if you want to play with these models, and every week there's new models coming out. It's really crazy. I mean, I try to follow up on this on a daily basis, and it's impossible even to be up to date. So those are the local ones. And then you have the cloud ones. The cloud ones, there's basically 4 or 5 big players. The one I use regularly on a daily basis is Claude Sonnet 3.5. It's actually 3.6 because they did a release a couple of months ago, but they kept the version number to 3.5. That's one of the best ones out there for coding assistance. It's unbelievable. The only downside is that the window context, the prompt size, is 200,000 tokens. One token is on average 3 characters, so you can send about 600,000 characters in one prompt, right? But then, of course, you have the other ones, OpenAI, Google. Google is a very interesting one because they were late in the game. They did invent, they did write a paper, Attention is All You Need, in 2017 at DeepMind. But they have now really catched up, and they are starting to release Gemini 2.0. The beauty of Gemini, the reason why I use it, two reasons. One, the window context. Just first of all, 2 years ago, the window context, the maximum window context was 4,000 tokens. That was the maximum you could put in a prompt. With Gemini, 2 million. 2 million, that's 3 times the trilogy of Lord of the Rings that you can put in one prompt. That's 40,000 lines of code on average in one prompt. So that means you can just put the full project in the prompt and then ask questions. It's going to cost you an arm and a leg. It's going to cost you like $10. Well, $5 for putting it in and $10 to get it back. But the cool thing is they have version 2.0 experimental version, which is free for the moment. So you can use it for free for a couple of months and just play with it. And then I have to add Mistral, because Mistral is the only European large language model out there from France. Hey, the Europeans are still in the race. But yeah, okay. They have a good set of models. I mean, CodeStrol, they just released 2 days ago a new version, and it has some good reviews. What they do is that they actually execute multiple benchmarks and then to see how good they are at different levels of benchmarks. I didn't put Amazon in there, but Amazon also has models called Nova. So, every big company has basically their own models, so to speak. Now, what you do need to know, if you're using cloud models, they will use your data, they will use your prompt to train the next version of the model. So from a privacy point of view, I did an AI course a couple of months ago in Belgium. If you have like an interesting project which is closed source, there's some intellectual property, etc., do not use a cloud model. Because they will train it, and you will see when they release a new version, all of a sudden you see your special comment way of documenting code, it will appear in the code examples. I've had that with Geoffrey, he did an open source project, Optaplanner, and has a special way of commenting. Well, when you do an Optaplanner generation of code, it will use his comment style. You go like, what the? So you have to be really careful with that. Now, the option is use local models, but they are not as powerful as the cloud models, or you could also do an on-premise installation. And some do sign a contract where they say, no, we will not use it. I would not believe that, right? So just be careful. So privacy is the important thing. So as I mentioned in the intro, I organize DevOps Belgium. That's the event I organize. And the beauty of organizing a tech conference is that I get a view of all the proposals which are submitted. And then I do a keyword cloud tag type of thing. And this is a keyword cloud tag from DevOps 2024. We had 900 proposals. And as you can see, large language models, generative AI, but also on the right side, LangChain4j, those were 2 or 3 keywords which were not present 2 years ago. So what we are seeing also for this DevOps is like this week, DevOps France and DevOps UK closed their CFP. The tracks which are really trending are the AI tracks. So it's clear that this is a momentum, this is happening, developers are excited about it. Well, I would say, because we are at CERN, I would say it's a quantum superposition state where we are both excited and frightened at the same time, right? Because there's also like this notion of how will this impact on our jobs? Will it replace us or not? Well, I'll come back to that one later, but what I want to talk about now is really how can we do AI coding assistance using modern Java? So have a full stack Java solution to do AI coding assistance. And Joe, talking about AI replacing your job, my belief is that AI will not replace your job. I think the projects that we do are more than 40,000 lines of code. Some projects have millions of lines of code. So the window context, they can't just handle it yet. But what I am 100% convinced is that developers using AI will replace your job. I'm totally convinced about that. If I look at myself, how productive I am by using, I work at home, I have no colleagues, well, not really colleagues for development, but I use AI assistants, I use large language models as my sparring partner. Before I start a new feature, I will talk to models and ask them their views of how to do this. I'll give them the full project, and then I'm basically talking to it. Like with Claude, you can create a project, you can even run it on your phone, so while you're sitting in the toilet, or on a train, or on a plane, you can discuss like new features, and you get new insights. And the level of quality is above average. I'm an average developer, so it's already very useful for me. And you should really try that. So out of curiosity, who's already using AI coding tools? Wow, okay, so I would say 80%. Just who is not using it at all? One hand? Wow, 2 hands? Okay. We should talk why. It's always interesting to know. So you're already using it. Okay, that's good. Who's using the Copilot? I would say 20%. Who's using Devox Genie? Oh, yeah, a few people. That's good. I'll try to convince you to use it. And that's the next slide. So 1.5 years ago, at the opening keynote of Devox Belgium, I actually had Anton from JetBrains on stage, where he showed the AI assistant in IntelliJ IDE. Who's using IntelliJ? I would say 80%. And what he demonstrated was a cloud-based AI coding assistant. And I was asking him, you can actually see the subtitle, are you going to open source and have a local large language model support? And I didn't get an answer. I was like, damn, okay, it looks like they're not going to do it. Yeah, maybe tomorrow. 4 months later, no reply, nothing happened. So I went like, okay, you know what, I'll develop it myself. I've never developed a plugin before for IntelliJ, but I used, of course, a large language model to help me, which now you can. And so I created something called Devox Genie. It's available, it's 100% free, it's open source. It's really my pet project. It's really to experiment with all these new, nice, shiny toys and see what it actually can bring as a value. And you can basically download it from the marketplace. So if you go into IntelliJ Marketplace, type in Devox, you will find it. I'm very proud that we're getting close to 9,000 downloads. We got 3 contributors already helping, and it's just a fun project. But it's something that I'm using also on a daily basis because it's free, and you know I can play with different models. So let me quickly show you a demo of that. There it goes. Do you see the screen? Yeah. And that often happens when I switch from machines. Let me stop. Force quit it. Okay, let's open it. Cool. So when you install, the beauty of the plugin is that it works on all the IntelliJ products. So if you're doing Python, which I'm doing a lot, it works also for that environment. So here I've got, this is like meta programming, because I'm using Devox Genie to improve Devox Genie. Right? So how does it work? You go to the marketplace, you install the plugin, you install Devox Genie, and that's what you get. You get this icon on the right. And then here you have the settings. So on the settings, you can select which models you want to use. So I have selected all the local models, and I've added 3 cloud models. Because what's the beauty here is that I can actually have a conversation with, for example, a local model, and then use the output to go to a cloud model and have that cloud model review the output from the local model. And then have a smarter cloud model review the other cloud model. And the end result is poetry. The end result is beautiful code, because we had 3 smart models actually reviewing each other. I mean, we're living science fiction. Seriously, I mean, who would have thought that that was possible in our lifetimes, right? So this is where you set it up. You can click on these icons to actually get you to the websites to get the keys. And then the important one I want to show is the prompts. There you can say the system prompt, so you're a Java developer expert. You can create some custom commands. But important here is the scan and copy project. Here you can define which file types you can copy in the prompt. So it can exclude or include certain directories, certain files, etc. And that way you create basically the window context based on these settings. There's a few other things I will not go into great detail. I'm here all afternoon. If you want more demos, just reach out to me and I'll show you, every feature if you want. And so what I can do here now is, for example, I can say calculate the tokens. So I've selected Anthropic version 3.5. I have 140,000 tokens for this project, so it basically went through the full project. And it says, okay, if you send it, it's going to cost me 0.4 euros, or dollars, sorry. That's nothing. I mean, seriously, I can ask here, I will not do it because it takes about 33 seconds, but I think I have it here somewhere. Here, I've got that one run this morning. It took 37 seconds to do this. And I basically do add project, so it adds the full project, as you can see on this progress bar. And then I ask, what are the top 10 refactorings I should do? And it basically goes through the code and says what I should actually refactor, etc. And then here I can say, okay, well, now go to Google and then say, let's use this free one, this one here, which has 2 million tokens, as you can see. And then I can say, review what Anthropic suggests. And typos are not important. It knows the semantic context, suggested and improve it. And I can just, oops, run it. Voila. The blue-colored line is showing that it's working. And this might take 2 minutes because it's a very sophisticated model. The downside as well, it's a bit like with cryptos. We're burning quite a bit of electricity by doing this as well. So it is like a dual, like with local models, you're just running it locally. It's your, wattage, your electricity. But there needs to be some sensibility there around that subject as well. It's like, how much does it take from a power perspective? I also support streaming, so it will then start streaming the response. But often what I do is that I often do very sophisticated requests, and I just let it run for a couple of minutes, and then I come back when I have my coffee, I came back, and then poof, it gives me the result. I'll keep that running, because it could be running for a couple of minutes. But that's how you actually can play with it. What you can also do, I still have a bit of time, you can also do, like, for example, not the full project, but you could go like to one package, for example, here, right-click, and then I can say, add files to prompt context. So I can just add the full files, or I can just add files manually here by just selecting the files. So you can either put the full project, or select specific files if you want to do a focus on one specific area that you want to refactor, or create some unit tests, or whatever. So that's very quickly, the Devoxx Genie way of doing it. When I did add project, it actually adds it to the clipboard. So the full project is in my clipboard. So what I can do as well is I can go to Anthropic, or so to Claude, and create, okay, I'm not logged in, so let's see if I can quickly do that. Still got a bit of minutes to spare. And I can create a project, paste the full project, the full code in the project, and then start chatting with the web interface. It looks like I'm not able to log in, so I'll skip that. But believe me, it does allow you to actually set that up that way as well. So that's a quick demo. Just come to me after this talk if you want. I'm more than happy to show more things, and let's come back to that one later on when Google has replied. When I did this demo last October, there was one attendee who actually tried it out, and he said, okay, I'm on an M3 Max. He used the local model Llama 3.2. With Llama 3.2, you have 132,000 tokens, so it would be too small for my Devoxx Genie, but a lot of projects, if you're doing microservices, that's more than enough. And he basically generated a README file purely just by adding the full project. And it looks like, looking at the acronyms with the F, it looks like he was very impressed. So yeah, have a look at it. All right, so that's Devoxx Genie. The cool thing about that is that it's already full developed in Java. JetBrains is Java. The plugin is Java. Unfortunately, you do have to do it in Swing, so it's Swing-based development, which is back from the old days. But the inference is still using Python. Yeah? So the next aim would be, of course, how can we do inference also in Java? Because I want to have 100% Java solution, just as a challenge. And that's where the new wave is coming, and that's where, Alfonso, you can definitely help me, right?
Yes, right. So as I mentioned, I work on the GraalVM team. We have, the project has many components. The main core of the project is the Graal compiler. It's a Java bytecode compiler. It's a JIT. But also has separate features, like we have an AOT, ahead of time compiler, so you can take all your Java application and turn it into a single executable without a JVM required. And within the AI space, there's also Tornado VM, which is not related to Oracle, but they're doing this trick where you can specify kernels in Java, and they directly compile the Java code with some constraints as like CUDA kernels. They support OpenCL, stuff like that. There's also Project Babylon. It's a similar shape project where they keep your Java code in a AST representation, and they also generate different kernels for different targets. There's Project Panama, which is already merged or is part of the standard Java that allows you to access external native code, so you can call native libraries, so you can actually access easier the native memory and so on.
And it's all about matrix multiplication. So inference, when you talk to a model, it's basically the bottleneck is matrix multiplications. So if you can enhance that, like using Panama Vector API, but also if you can do that on the GPU, then of course we can have much faster inference, right? Because that's the bottleneck, right?
Yeah.
And so there are actually 2 projects that I invited at DevOps Belgium last year. One is Llama 3.java from Alfonso, and the other one is from Jake, jlama, which if we still have enough time, I'll quickly discuss that. But there's basically 2 solutions completely written in Java, well worth checking out, and we'll have a closer look at Llama 3.java.
Right. So last year in October, we presented this project. Here's my colleague Alina there. Here's the GitHub. It's open source on GitHub, Llama 3.java. It's a tiny CLI application where you can just pass a model and you have a chat interface. But you can also do completions and all kind of this stuff. So it was presented again in DevOps Belgium. The presentation has more details, so here we'll just cover some highlights. Right. So what is Llama 3? So Llama 3 is just the inference Llama inference implemented in a single Java file. You might wonder why, right? But it's more than that. So it's not only a single Java file. There's no dependencies. So the whole inference, all the transformer model detention, all these magically sounding things are implemented using just arrays and for loops. There's nothing else. There's no magic. I can guarantee, as I mentioned, everyone in this room may understand what's going on. It's not really that difficult. So you multiply some matrices, and it talks back to you, and that's it. There's no secret sauce, nothing.
I don't agree. I mean, I looked at the file, I was like, what the hell is going on here? There's a lot of mathematics going on there. So I used to use a large language model to explain what these methods are doing, and it's rather sophisticated, but the beauty is it's all in one file. So you can, if you really, it's like boys, right? You want to open the toy and see what's inside. Yeah. Well, this is a nice opportunity to do that, actually.
Right. So, and for inference, so the inference alone is not enough. So you need more code to read the model, read the matrices. This is the GUF format. Basically, it's the de facto format used by Llama CPP, which is the C++ implementation for inference. There's also tokenization. So tokenization is like a huge problem because all different models, or many different models, use different tokenizers. And this is the way you cut or divide your text into smaller atoms, like integers. So because the models don't understand text, they understand tokens. So we have to implement the tokenizer. And of course, yeah, the inference logic, you only using for loops and arrays. That's it. And again, the models, for reasons, it's not that you load the weights only using floats. The floats can be like float 16, which is like smaller floats, or they can be quantized. So the weights of the model can be even somehow compressed, so they're smaller, so they can be processed, can be executed faster. So all this we have to implement it in pure Java again.
Yeah. And there's also a tendency to actually do experimentation where you go the other extreme. Like you have bitnets, where they don't use floats, they just use 0, 1, and -1. And they try to see if they can still have knowledgeable information in the weights just by using 3 values. And what it seems is that if you take a 400 billion parameter model and you use bitnets, it's still knowledgeable. It's still very good, actually. But the beauty is that the size is much more smaller, so you can actually run it on one machine, which normally a 400 billion parameter model it doesn't fit on one machine.
Right. And in order to make it fast, so the Growl compiler is amazing. And it can do some octo-vectorization, so it can turn some of your code, some patterns, into fast vector code instructions for the CPU. But let's say it's not that easy with generic algorithms. And in this case, it's not just a simple matrix vector, it's a quantized matrix multiplication. So it's not like your floats are one after the other. They're somehow packed, so it's not as trivial as a simple matrix vector multiplication. So that's why we're using the vector API from Java to guarantee that the compiled code will use the vector instruction from your CPU. And this works on Mac. Somehow it's not as good as it could be, but and of course on Intel platforms. And finally, native image support. So native image is our ahead-of-time compiler. Who have heard of GraalVM? Yes, I say maybe 50% of the room. What about native image? Yeah, 20% maybe. Right, so native image is, as I mentioned, or ahead-of-time compiler. You can take Java application and turn it into an executable. Everything you need will be there, so this executable will contain garbage collector. There's no compiler, you don't need the JIT, so basically all the code is ahead-of-time compiled. So you can compile llama3.java using our native image compiler as an executable. It's a standalone executable that does not need a JVM to run.
Yeah, cool.
And finally, of course, since we are doing ahead-of-time compiling, why not preloading the model while using our compiler? So basically, this means that you can pre-parse the tokenizers or all the metadata from the model at build time. So I'll quickly show later on. So like, how can you really get rid of the startup time? So I'll show you, usually when you run llama CPP or llama or whatever, there's like 1 second delay between you execute the command, and the time you actually start getting tokens out. With this technique, you can actually, just in the moment you hit enter, it will start spitting tokens right away. There's no delay, literally, for inference.
And the time to first token is TTFT acronym
right,
I
time
learned
to first
this
token,
morning.
Yeah, TFT, yes. Right, so as I mentioned, this is meant for GraalVM, and we use 2 main pillars, let's say like 2 APIs to make it fast. And this one actually make the code nicer. Is to, when you load the model, so the model is just a big file with matrices in there. So literally just floats or quantized matrices. And we use the memory API, memory segment for those who knows, like to memory map the file into memory. And it has some nice things with, like, if you start 2 processes, the memory mapping will not do it twice. So basically, you can share the weights. So you don't spare memory. You don't have to copy from a file to memory. You just use memory mapping, and it just works perfectly fine. And as I mentioned again, IDEs is also supported on native image. Native image is a bit special. There are some constraints. You cannot dynamically load code or new classes. But this part is fully supported on native image.
But like for Mac, there's still a bit of work to be done there?
Yes, so the memory part works. The frame function calling is still not there yet, but as soon as it's finished, I think it will be just enabled.
So for
yes.
So yes. For DevOps Belgium 2025?
Yes.
That would be nice, thank you.
Right,
I'm a Mac user, so that's why I need to ask, right?
Right, so the JIT works, but the native image part still not. So the other pillar is the vector API. So the vector API, as I mentioned, enables to ensure that, so you write your code in a high-level form, agnostic of the CPU or the architecture you're using, and the compiler will ensure that you get very fast routine. So the compile code will take advantage of I would say like AVX, that's what wants the vector instructions in Intel, or the Neon, or whatever is in the other platforms.
So it's really write once, run anywhere.
Yeah, exactly. So, but it's like kind of the last mile. So basically, if you use a vector API, you get like 2x token throughput. It's crazy. I mean, for this stuff, and it's actually very high level. You don't have to write any assembly or anything like that. It's just very pristine, very nice code. And
it's already the 9th edition, right? The 9th incubator of that.
Yeah, it's been incubating. Incubating means like a preview feature. It's not yet part of the standard Java library, but I hope soon or after Project Valhalla lands would take also some time, but yeah,
sure.
It's there. You can actually use it from Java, it's fine. So
and that's why you need to do like enable preview, right?
Yeah, exactly. So exactly. So you still need to pass some flags to enable it, but it's perfectly there. You can test it, and it works pretty good.
Yeah, cool.
Right. So since the last talk at DevOps Belgium, there are some new features that we added. For example, the weights on these models can be in some versions float 16 or bfloat 16. Even if Java does not support this format, Java llama 3.java kind of supports the weight. So all the computations happen in flow 32, so it's full precision or half precision. But in this case, the weights can be perfectly fine in these formats. It's kind of magic because Java doesn't support it, but it just runs. So yeah, it's a nice trick where you load the float 16 to a short, and then you do some bit flips, and boom, you have a float 32, and then you go on, right?
But that approach wouldn't work with bitnets, right?
Well, with bitnets, I don't know the format, so it depends how, but it's a similar thing. So the bottleneck is the memory. So basically, you need to read something from memory and unpack to get to float 32. I get with bitnets, you will do the same. So you read something, do some bit tricks to get the floats, and then
Because you said like the matrix multiplications would be different for bitnets than for...
Well, yeah, exactly. In that case, I guess you will do it in a different... So you have to re-implement the quantized multiplication, yes.
Because there are the specific models for that as well,
So another one is AVX 512. This is the newest and Chinese instruction set from Intel or AMD CPUs. The nice things for Llama 3, the Java, is that I didn't have to write any single line of code for AVX 512. Nothing, nada, right? I just had to kind of do some changes to allow it to use the larger vectors, because this actually give you very big vectors. Vectors is kind of like you have one array of many elements, and you can do operations on these vectors where all elements are affected at once. So no assembly code, nothing required for this. It just works. Also, we got some contributions. For example, now we can ingest the prompts in parallel. For those who don't know, the models, have you heard, have I don't know, 128K tokens of context length, and then there's but this context is kind of limited. So in the sense that you have, yes, 128K of input, but then your output is maybe 4K or 8K. Yeah. And the reason is because you can ingest these tokens in parallel. So the prompt ingestion can be done in parallel. Because if you know the tokens in advance, instead of doing one by one, you can do it, I don't know, 128 at a time, and it's actually faster. But the inference part, was actually the model start spitting new tokens, that you have to do one by one. So now, before, it was like the inference and the prompt ingestion in Llama 3 was done at the same speed. Now it's parallel.
Yeah. And I think the other opportunity still is like the KV cache that you could add.
Yes, we also have a pull request, yes, to cache your prompt. So you can run the prompt once and cache it. This is still an open pull request. So the next time you run the program, you can directly load all the pre-computation, the cache prompt you have, and basically start from the point where you left off, right? Yes.
I mean, the techniques that we are seeing, and it's really very interesting. They come all with new papers and new approaches and thinking out of the box. It's really exciting to see how that all is evolving.
Right, and the other one is my colleagues in the Graal compiler team. They're doing a great job. So now the Graal compiler is kind of 20% faster doing this kind of computation, this kind of workloads. As I mentioned, it is not trivial, like simple dot products and stuff. So it's a little bit more involved computations because it's quantized multiplication. So you have to do a little bit more of shuffling and stuff. So the Graal compiler is actually doing a great job at making these workloads very fast.
So, but it's 20% faster than 4 months ago, basically, from Belgium.
Well, it's like 10% faster than 4 months ago.
Okay.
So 4 months ago was already a little bit faster.
Because we were already competing with Llama CPP. When I saw that graph, it's like, what?
Yes, I'll get there.
I get goosebumps, seriously. It's geeking, right? But it's like, we're doing Java on a higher level, generating native code, and it's actually getting faster than already CPP or C++.
Right, and this is not, so the version of Graal VM that can run this at speed is not released yet. So this is kind of an experimental phase. You can download the early access builds, so you get actually the speed you want.
Yeah, nice.
Right.
And that's the command you need to use. So let's have a demo. Let's switch the HDMI.
Yeah.
You're there? Yeah. Watch out for the water. Yeah, it's there.
Does it work? Can you
yes,
see?
it works.
So let's first show quickly what Llama 3 is. So here's the LS, so like just listing, and you see a single Java file. That's it. So Llama 3, the Java is the single Java file. It's a large Java file, but it's not that bad. So the other things you see, well, the README, there's the models you can see here, but let's see, just quickly pick at what Llama 3.
And you manually downloaded those
Yeah, you have to manually download from other sites. Yeah. So if we open Llama 3.java, it's just a regular Java program. I mean, if maybe we go to forward.
Did I see JBang there as well at the top?
Yes, so I use usually JBang to run this. Yeah, it's just for convenience. Yeah. Maybe if let's do it around. So here's the forward. Forward is basically what does the inference. And as you can see here, just for loops, and you have the mud moles, and then you have this is the rotation. So it's literally just plain Java code. There's nothing crazy there.
Well, I wouldn't say plain Java code. Yeah.
Well, it's some code that
it's definitely some code. Yeah.
Yeah. Well, you have this parallel stuff just to process things, many tokens at the same time, but it's really nothing crazy, right? So I would say like maybe the forward method is maybe 100 something lines of code. It's not really crazy. Yeah. So just for reference, the whole file is 2,500 lines.
Nice.
You may think that it's actually big, but it's not that big. So it is, as in the conference I mentioned, it is smaller than the string class. It is smaller than the, I don't know, hash map class. Wow. Smaller than class. Wow. So it's in the same league as array list.
And you have comments as well, right?
So yeah. It's heavily commented. So you have comments everywhere, right? So I would say like for something that has all the tokenization, all the formatting, all the inference, with all the quantization support, 2,500 lines is not much, right? So it's just that's the peak of the code. So let's see how it runs. So like this JBank, just a utility I used to run it, to run this llama3.java. We specify a model, and the model, let's use this the Q4. This is one of the quantizations.
So that's the one from Meta.
Yeah, exactly. So this is like 3.21 billion. It's like the smallest model from Meta. Was released last year. So by default, what you get is this. So it loads the weights. It's like 200 something milliseconds to load, and you can say hi. Boom. There we go. So
wow.
Who are you?
50 tokens per second. That's a lot. Just so you know.
56. So that's the kind of the speed you get with the smaller models. You can, of course, try the models, and of course, the larger, the slower it is. You can see here, like the speed is perfectly fine. Another thing I want to show you.
He is running this on Linux, by the way, right?
Yeah, this is Linux. So it's kind of a beefy machine, but it's not something crazy. Yeah. The Macs will do a much better job. So the other one I can show you is this Llama 3. So Llama 3 is an executable. I can show you here.
65 megabytes?
Yes. Well, it's kind of big because it preloads the tokenizer. So this is already the version that is ahead of time compiled with the preloaded model. So
the model is already in the 65 meg?
No, not the model. So the metadata of the model, not the weight. So basically what it does is when you run the model using this we'll see quickly, the metadata are already preloaded. So the only thing you have to do is load the weights, memory map them, right? So let's see. So maybe you remember before was 300 milliseconds to load the model. Let's see how
native.
Yeah. So maybe let's use the same one just for
reference.
Oops. Yes. Llama, right, Q4. Boom, instant.
1 millisecond?
Nothing.
Seriously?
Right, so in the moment you hit enter, it start, I mean, maybe we can show you like a different example when I say like instruct, maybe not this one, so like directly prompt.
If Larry Ellison sees this, you know, he's going to create a new product. I mean, 1 millisecond.
True. So it's just, this is for right. Right. So maybe you cannot see, but in the moment I hit enter, boom. So it's like really like it starts splitting the tokens.
Wow.
Right. So that's kind of the speed or the time to first token you can get if you do this ahead of time build time tricks with native image and Graal. Right. So more usages we can give. So we can try other. So we can use these models for small questions. As I mentioned, these models are small.
0 milliseconds.
Small, like, yeah. You cannot even measure the delay. So these ones are not very smart, let's say, but they actually capable of doing some auto-completion or answering certain basic questions. For example, you can say, okay, maybe explain this shell command. Oops, typos don't matter. So let's find something like maybe find name, something I will use myself often to Java, something like this. Not really trivial. Tharks, yes, .l.
So you're asking the model, explain me this command?
Yes.
Boom.
Oh, yeah.
Yeah, really fast.
So, right. So
and this is all locally running, purely in Java, but it's a native app, so it's basically assembly.
Right. And I think that's it. Maybe.
Yeah. Well, we still got 5 minutes, so let's make sure that we do have the last slides.
Right.
Maybe one thing is that you don't support a web interface, right? So if I want to integrate it, well, what I did is that I basically built a Spring Boot app around his code.
Right.
So that way the Spring Boot app created a REST interface so I could actually include it using the DevOps Genie. So DevOps Genie talks to his one. But the beauty is I run his code in another project in IntelliJ in debug mode. So I can actually go through the code and see how these large language models work step by step. So I can debug from the prompt to the execution fully in IntelliJ, which is like really nice. I mean, that's really beauty. But you do need to wrap it yourself. And just as a, there are alternatives, like Jake did also a presentation at DevOps Belgium. He's from the US, which is called jlama. If you take a picture of that, it will take you to his slides or his presentation. And it's very similar, but he didn't do it in one file. He did it in very multiple files, but the code is beautifully done. I mean, I started developing my own vector database because I thought I had the need to do that. Then I found his implementation, and I went like, okay, no, I'll stop. I'll just use your code. And it's also using JBang, and he does have a REST interface. So if you do jlama REST API, and then a model, and auto-download. It will auto-download the model if you don't have it yet on your machine. And then because it's an OpenAI compliant REST interface, you can just use DevOps Genie using a custom OpenAI endpoint and just talk to his inference engine. But of course, he doesn't have the GraalVM spiciness. That's why I'm really looking forward to what you guys. Yeah. Well, yeah, he'll probably do that as well. We still got 3 minutes. I quickly want to talk about LLM sharding. Who knows about database sharding? Everybody knows that? Well, what's happening is that they're now sharding also on large language models. The reason is that these models, the big ones, like the 400 billion models, they don't run on one machine. So what they do, there are projects where they actually are sharding the model over multiple instances. There was a talk at DevOps Belgium by Mohamed from a project called EXO. The link to his talk is in the QR code. And this is in Python, but it's specifically focused on silicon, Apple silicon. And so this is an example of my machines at home. So I run the application, a Python app, on 3 machines. They talk to each other, so they know the network by UDP. And then they actually do layered, so they do like 5 layers on one machine, 10 layers on that machine, another 5 layers on that machine. And the result is that you can run bigger models on multiple machines. The inference will not be faster, but the fact that you can just run bigger models will mean that you will get better quality responses. So that's very exciting. And of course, Jake did the same thing. He actually developed this as well. He even did sharding on attention heads and sharding by layer, whatever that means, but we don't have time to go into that because you know what that means. I don't. But so these are trends that we are seeing as well, is that basically, if you have a small company, you want to run, and privacy is important, you can run big models like from Meta on-premise using this technique. So that's pretty cool. So it's exciting times. I mean, seriously, I am really excited that Java can actually deliver, that I don't have to just do Python development constantly, because a lot of the innovation is happening first in Python because of data scientists, etc. But it's clear Java can definitely do it.
Yeah, who have thought that if you think for a moment, not even Python can do it. So if you run the model in Python, you need PyTorch or even NumPy or something like that. But you can actually run the model at speed in a CPU, just using pure Java.
And Python is slow, right? I mean, Python doesn't have a good reputation of being very fast.
Exactly. So yeah, I mean, all these libraries, they're all leveraged, like C code, and they call like the GPUs and all this stuff. But again, so maybe you can only do this at speed, maybe on C++, maybe Rust, Zig, and also in Java, right?
Yeah, that's great. So I'm really looking forward to DevOps Belgium in October, because I'm really looking forward to what you guys are going to do with the GraalVM team, etc. And exciting times. We still have 1 minute. Thank you for your attention. Any questions? Yeah?
Hi there. Thank you very much for your presentation. Very I have a question regarding DevOps Genie. So I've been using Cursor as my
Yes.
IDE, and so for those of you who don't know, it's basically a VS Code with the AI features on top of it. And the feature I really find useful is
Yeah, yes. So let me repeat the question. Cursor is like an agentic system. It's basically a fork of VS Code where they're doing, because the next big buzz is agentic or AI agents, right? Where you give it a prompt and it generates your full project. And what I've done in Devoxini, I didn't show it, but I have RAG support as well, where it starts a Docker instance and it will actually do a vectorization of your full project, so you can do similarity search and have more a smart window context. Instead of doing brute force your full project in prompt, it will, based on your prompt, do a semantic search and include only the files which are related to your request and do that. Like this week is a bit busy and I've just had a holiday, but like from next week onwards, I'm starting to actually I will add agentic features to the plugin, similar to what Cursor is doing, and there's a few other ones which are really going the next level. I've got a working prototype in Python, but I now need to ask the model to rewrite it in Java for me. So anyway, that's how it goes. I think we're out of time. Thank you for your attention. We're still here the whole afternoon. Please come to us if you have questions or if you want a demo, and thank you very much.
Good job. Yeah.